So today we are gonna learn about the polynomials. And as we know that polynomial is a part of mathematics, so why not start with the basics of maths first? Maths, as we know, consists of numbers and letters. And when we speak of numbers, we know that every numbers bears a fixed value which do not change with respect to time and are hence known as constants. Whereas letters, they can assume any value with respect to time and hence known as variables. And here are some examples of numbers. 5, root of 2, minus 8. And then we have some examples of letters such as X, Y, and beta. So can we now say that maths deals with constants instead of numbers and variables instead of letters? And the combination of these two we will see eventually leads us to polynomials. So now the question is, how do we combine a constant and a variable? Well, by using operators such as addition, subtraction, multiplication, and division. Let's assume that you step into a cafe and place an order for a burger, and the representative over there says that if you add a donut to your order, you will get a discount of 20%. So now you decide to go for the burger, and then you're left with two different units, a burger and a donut. Similarly, let's suppose you walk into a library, pick some books, but then later you decide to remove a book from the pile. Here also, aren't we left with two separate units, the one that you want and the one that you do not? Now let's take another example. Suppose you go to the market and buy a pen, but then that's too small for you. So you go and return it and instead buy a pen which is twice the size of the one you initially purchased. So aren't you left with just one single pen which size is twice that of the one you purchased earlier? Similarly, let's say you bought a pen which is quite large for you. So you go to the market, return it, and in exchange of it, you get a pen whose size is half that of the one you purchased earlier. So aren't you left with just one single pen now? So can we now say that polynomials are a combination of constants and variables that are separated by mathematical operators such as plus and minus but unified by symbols such as multiplication and division? Now here are some more examples of polynomials. As you can see, 3x square represents one single term which is separated by the symbol minus, and then 15 is another term. Similarly, 18x is one single term which is separated from 3 by the symbol minus. If you look carefully at all the polynomials above, you will see that none of them bears a equal to sign, and hence they are known as expression. So the question is, what is an expression then? Well, we know what expression means. Like for example, if I say 2 pi r, what is the first thing that comes into your head? A circle, isn't it? Without even saying that, think of a circle. Similarly, what comes to your mind if I say a square? Doesn't the picture of a square shows up inside your mind? Now tell me, what comes into your mind if I say half base into height? Well, a triangle pops up inside your head. So when we speak of an expression, we don't have to explicitly say what we want to show. Rather, we just mean something very similar to it. So can we now say that polynomial is basically a type of mathematical expressions that is made by using or taking into account constants and variables. Now that we know that polynomials are expression, the question now comes, what information do we derive from a polynomial? Well, the very first thing is that the number of terms tells us what kind of polynomials we can have. Then what kind of geometrical figure try to represent, and then the possible number of solutions. So we can even classify the polynomials with respect to the number of terms and the degree of the variables. So the first kind of polynomials that we come across is the monomials, where we can clearly see that the monomials are represented by one single terms such as 5, 7x, x upon 2, a square, minus 9, y cube. And then comes the other kind, which is the binomial. Binomial means 2. So here you can see that the expressions or the number of terms are separated by mathematical operators such as minus or plus. As in the example, 3x minus 5, a square minus 9, y upon 3 minus 5 upon 2, etc. And then comes the trinomial, which means 3 number of terms in an expression, as in 2x square minus 6x plus 4, or 8y cube minus 2y square plus 6b, etc. And then comes the polynomial, which means at least or more than 3 number of terms should be there. And here are some examples of the polynomials. Now we can even discuss the type of polynomials according to its shape, as in linear polynomial, quadratic polynomial, cubic polynomial, and then the biquadratic polynomial. As you will see that the linear polynomial are represented by the expression something like 2x minus 4, whose degree of the variable, that is x, is 1. And if you look at the quadratic, the degree of the variable is 2. If you look at the cubic, the degree of the variable is 3. And if you look at the biquadratic, the degree of the variable a is 4. Degree means the highest power to which a variable is raised to. Now let us have a look at some examples. So here we have 2x minus 4. As you can see that the degree of x is 1. So it represents a linear polynomial. So we use the graph method to check whether we are going to have a line or not. So let's plot the graph and check. And as we can clearly see that we are having a straight line that passes through the value 2. Let's take another example. Let's take 2x square plus 3x plus 1. As we can see that the degree is 2, so it should give us a quadratic values. So after solving, we get two values which represents, one could be the length and the other could be the breadth of a quadratic polynomial. Whenever we have a look at a polynomial, the very first thing that we see is the number of terms that it contains, the variable that's used, and the third is degree of a variable, which is the most important one. So let's solve some more questions now. 7x minus 49. As we can see that the number of terms is 2. The variables used is x, and the degree of this expression is 1. That means it's a linear polynomial and we should get a straight line if we solve this equation or expression. As you can clearly see, x has one single value that could be the magnitude of the length of a line. Now here is another question, 4y square minus 8, where the number of terms is 2, the variable used is y, and the degree is 2. That means we can have two possible solutions. Therefore, it's a quadratic polynomial and x will have two values. So after solving this, we see that the value of y comes as plus of root 2 and minus of root 2. Now one of them could be length and the other could be breadth of a quadratic. You can even check this question by using the graphical method. So plot a graph, get the values of y and x, and then check whether the curve that you are getting is intercepting the y-axis at two different places. I hope you enjoyed this video. Thank you for watching and have a good day.